Can you see this?
Yes.
Okay, so this is what is happening right now. Wait, So this graph represents the number of daily cases of COVID-19 in Malaysia. This is in 2020. Okay, so the source is from the Ministry of Health Malaysia. Okay, I'm showing you the graph over here. You see it move up and down like this. Okay, can you guess what are we going to learn later on in the next chapter? No guessing?
Distribution.
Statistic.
Yeah, correct, the distribution. So if you look at the distribution of the data over here, because we implemented the MCO, we start to implement it, so then the data go down. Okay, can you imagine what will happen if the MCO is not implemented?
Exponential graph.
Okay, so it will spike up. Okay, so that is what we are going to learn in this chapter, the measures of dispersion for group data. Do you still remember you learned more or less the same thing in Form 4?
Yes.
What did you learn in Form 4? Do you still remember? Don't remember, right?
The variance and everything, madam.
Correct. So I move on. Before that, just to let you know, the mathematician involved of this chapter, this is the one you can see in your book. His name is William Playfair. Okay, so we move on to what you have learned in Form 4. In Form 4, you learn about the measure of dispersion for ungrouped data. Ungrouped data means the data is scattered around. It is not grouped according to the classes. So in this Form 4 syllabus over here, you learn the 3 types of data representation, the stem and leaf plot, dot plot, box plot. And then the measure of dispersion that you learn, you still remember you learn the range. How to get the range, do you still remember?
Maximum minus minimum.
Yes, very good. Maximum minus a minimum value. Then you learn the quartile, and then you get the interquartile range. So to get the interquartile range, it is the third quartile minus the first quartile. After that, you learn about variance. So there are 4 types of formula, which is more or less the same. Formula of variance, which is the total of x minus mean in bracket squared over the number of data. If it involves the frequency table, then this is the formula. And then from variance, you learn about standard deviation, that is without the square. So you square it on the right. So this is the normal data because it depends on the number of data over here. And then this is the one that involves frequency table. Okay, now we move on. So you can see the title, the measure of dispersion for ungrouped data, that is in Form 4. So now you are going to learn the measure of dispersion for group data. Group means it is grouped into classes. For example, from 0 to 5, how much is the frequency and so on. Okay, so the data representation that you are going to learn in this chapter is histogram and frequency polygon. After that, you are going to learn ogive and box plot. Box plot, you learned this before, so it's just an add-on. And then the measures of dispersion that you are going to learn, as usual, range, interquartile range, which is going to include percentile, and variance, also the same thing. So you can see the formula for variance is actually the same as the one that you have learned before. Same with the standard deviation. Okay, it is the square root of the total fx squared over total f minus mean squared. It's actually the same. Okay, it's actually the same, you can compare. Now we move on. Are you okay so far?
Yes.
Yes.
Okay, now we are going to look at 7.1, dispersion. How to construct histogram and frequency polygon. So I'm going to go through fast over here. In Form 4, you have learned about the ways to interpret the dispersion of ungrouped data based on the stem and leaf plots and dot plots, and also box plots. We can observe dispersion for a group data by constructing histogram and frequency polygon. Okay, so prior to that, you need to know the class interval. So there are a few important things that you need to know. First, you need to know the class interval, the lower limit, upper limit, midpoint, lower boundary, upper boundary, and cumulative frequency. This is another thing like cumulative frequency that can be obtained from a frequency table. But this one you have learned twice already, whereby you learn it in Form 3 and then Form 4 also you learn on how to solve the question on cumulative frequency. So it's easy for you. So you just need to learn on these 5 things. 1, 2, 3, 4, 6. 5, 6. Okay, what are all these? Is very simple. You don't have to worry. So let's see the mind mobilization one over here. This one I'm just going to discuss with you on how to get the answer. Okay, so if you look at mind mobilization, do you have your book with you? Maybe it's very small when I present over here. Okay, never mind. We look at the aim. The aim is for you to recognize the lower limit, upper limit, midpoint, lower boundary, and upper boundary of a set of data. So this is the set of data. Before we start over here, you need to find out how many total number of set of data over here is given. How many number? 1, 2, 3, 4. 4 times
20.
5. Yes, we have 20 numbers over here. Okay, so you look at the steps given. The data shows the amount of daily pocket money in RM received by 20 pupils on a particular day. So you assume in your class you have 20 classmates over there, including you. So this is the pocket money that is received by all of you on a particular day. Okay, now, number 1, identify the smallest data and the largest data. Can you see which one is the smallest data over here?
1.
Yeah, 1 is the smallest data. Which one is the largest?
15. 15.
Okay, thank you. So number 1 you have done. Now we look at number 2. By referring to the data, group the data into 3, 4, 5, or 6 parts in sequence. For example, a group of 3 uniform parts means 1 to 5, 6 to 10, 11 to 15. Okay, do you understand this one? This is grouped into 3 uniform parts. So that is the first one. So you will have 3 classes consisting from, because you said you have 20 pupils, right? And then from the maximum and minimum value that we have up to 15. So you are going to divide by 3, meaning that one class you will have 5 frequency. Okay, so 1 to 5, not frequency, sorry, 5 range. 1 to 5, 6 to 10, and then 11 to 15. Okay, how about if I want you to group it into 1, 2, 3, 4, 5, 5 classes? Can you tell me what will be the range of the class?
3.
3.
3, very good. How do you get the 3? Because you use 15, divide by
5.
you get a 3, right? So meaning the first class will be 1 to 3. The second class will be 4 to 6. The third one will be 7 to 9, followed by 10 to 12, and then 13 to 15. So you see, your minimum value and the maximum value or the largest data are all included. Okay, so do you have any problem in forming the class interval?
No.
You just need to divide. What do? Divide the largest value with the number of class interval required. So we call this class interval. Okay, so second one done. Now we look at number 3. By using the tally method, choose and insert the data according to the parts of the group. Okay, so I'm going to do this here. I'm going to insert into this diagram given at the bottom. So 1, 2, 3, I'm going to use the one that we did just now for 5 classes. So 1, 2, 3, 4 to 6, 7 to 9, 10 to 12, and then 13 to 15. Okay, now if you go back to what we have here, how much number of frequency for number 1 to 3? How many? This is how you check, 1, 2, 3. Only 3 data, right? So you fill in the frequency as 3. Can somebody off your mic? Can someone off your mic? Thank you. Okay, we continue here. Now, for class 4 to 6, can you help me to find out how many number of frequency for 4 to 6? 4 to 6. I can use a blue one. How many?
3.
Sure. 4 to 6 means from 4 to 6. 4, 1, 2, 3,
5.
4,
5.
5. Okay, so the answer is 5. What about 7 to 9? I'm going to use different color again. How much is the frequency? 1, 2, 3, 4, 5. Yeah, it's 6. Okay. What about the next one? 10 to 12?
4.
Okay. 1, 2, 3, 4. It's 4. And then 13 to 15. How many left?
2.
You can see this and this left. So you have 2 left. Okay. So we have done the first 2 columns, the pocket money with the frequency. This one, we don't write down the class interval. You refer to in the question given. If they said pocket money, then you replace it with pocket money and then put down the unit in RM. So now we are entering into the next step, step 4. Step 4 over here, with the very long description, I think you might confuse about it, but I'm not going to explain this part. So I'm just going to straight jump into this on how to get the upper limit and the lower limit. It is very simple. The lower limit, upper limit, you just need to refer to the range of the class. Okay, so the lower limit is the lowest value in the range given. Okay, and the upper limit is the largest value in the range given. So for this one, the first one, we already can get the answer. The lower limit, is 1. Upper limit is 3. What about the next class? Can you give me the lower limit and upper limit? Can or not?
4 and 6.
6.
Yes, very good. 4 and 6. For the third class, what is this?
7 and 9.
9. For the fifth class? Fourth class?
10 and 12.
Yes. What about the last one?
13 and 15.
Correct. So this is the lower limit and upper limit. Now we are going to get the midpoint. So midpoint is in between the lower limit and upper limit, or you can just determine from the class given. Okay? Or what you can do is you are just going to add the upper limit with the lower limit and then you divide by 2. That will be the midpoint. So in between this number 1, 2, 3, which number is in the middle?
2.
2 is in the middle, right? So that is the midpoint. What about the next one? 4 and 6?
5.
And then this one will be
8.
11. And the last one?
12.
14. 14. Correct. Okay, so these 2 done already. Now step 4. Step 4, 1 and 2. They want you to determine. They didn't write down over here. Number 1 is representing the lower boundary. And number 2 is representing the upper boundary. So, also very simple. The lower boundary and the upper boundary, we can refer to the diagram given. Okay, just refer to the class given over here. The lower boundary is the upper limit. You know, this one is the upper limit for the class. This one is the lower limit for the class, right? So if you want to get the lower boundary, it will be the upper limit of the class before it. So over here, because it is already minimum over here, we can't get anything. So I'm not going to show you on how to get the lower boundary for this one, but then we can go to the next here, the next class. Yeah, I want to write not this. Right, Okay, we are going to enter into the second class so that it's easier for us to get the lower limit and upper limit. Again, I repeat, lower boundary is the upper limit of the class before it, plus the lower limit of the class, which is 4, and then you divide by 2. So it will be 3 plus 4 divided by 2. That will be 7 divided by 2. 7 divided by 2 is 3.5. So I'm going to fill this in here. 3.5 is the lower boundary. So you can see some similarity later on. How about the upper boundary? The upper boundary will be the upper limit of the class, 6, plus the lower limit of the class after it, 7. After you plus, you divide by 2. So 6 plus 7 is 13. 13 divided by 2 is 6.5. So you can see actually the lower limit is just a 0.5 before number 4 and the upper limit is 6. You just have to add another 0.5. What about this class? Can you tell me what is the lower limit?
6.5.
Correct, 6.5. The upper limit?
9.5.
Very good. What about the next class here? This one?
9.5.
Correct, 9.5 and 12.5. And the last one will be 12.5 and 15.5. So you can see the common number actually. This upper limit is the same as the next lower limit. This upper limit is the same as the next lower limit. Okay, so that is the meaning of upper limit and lower limit. Are you okay so far?
Yes.
Yes, I move on.
Okay.
Okay, so
Madam,
yeah.
if the number is not in the data, like for the lower limit, can it has 13, but 13 is not in the data. Can we do that?
Can. You mean
What?
13 is not in the set of the data up here, is it?
Yes.
Yes, can. That is what you do because the purpose we found out all this is for us to draw the histogram and also the frequency polygon later on. Okay, so although we don't have the number in that set of data, but then we still have the interval class. Okay, class interval. So now we look at this. This is the result from the finding actually from what we have learned just now. So to get the size of the class interval, it is the largest value minus the smallest data value divided by number of classes. This is what you did earlier because you found earlier the largest data value is 15 and then the smallest data value is 1. So to get the size of class interval, you use 15 minus 1 and then you divide by the number of classes. Okay, but over here for this one, we just use 15 to divide by it, then to get the number of the class interval, like just now, this one. Okay, so I carry on. Now, lower limit is the smallest value and upper limit is the largest value of the class. So we know that to get the midpoint, it will be lower limit plus the upper limit and you divide by 2. Midpoint, you understand, right? Just now we already found the midpoint. Okay, and then for lower boundary, it will be the upper limit of the class before it. This one very long, you might not understand. So what you need to do is you just remember to get the lower boundary, this lower boundary over here, you are going to add the class before it, the upper limit, plus the lower limit. Okay, the lower limit of that class, and then you divide by 2. So 4 plus 3 is 7. 7 divided by 2, you get a 3.5. That is to get the lower boundary. Same with the upper boundary over here. You are going to add the upper limit of that class with the lower limit of the class next to it. After you add on, you divide by 2, you get 6.5. Are you okay with this?
Yes.
Yes. Okay, so I move on. Now we look at example 1 here. Okay, the data on the right shows the heights to the nearest centimeter of a group of from 5 pupils. So you have a set of data. So before you start on with on the rest of the question, we always find out how many numbers of data that we have over here. How many data?
20.
20, correct. We have 20 data. Okay, now let us see what is the requirement. A, determine the class interval for the data if the number of the classes required is 6. So actually, we just follow what is given in the formula lah. To get the size of the class interval, use the largest data value minus the smallest data value, divide by the number of classes. Okay, so over here, if you look at the number given, which one is the smallest data value? Can you identify?
145.
145. Which one is the largest data value?
173.
Very good, 173. So we can get the class interval already, right? By using 173 class interval, 173 minus 145, and then you divide by the number of classes required. How many classes required?
6.
6, correct. You divide by 6. So 173 minus 145 divided by 6. Actually, you are going to get the decimal places, which is 4.7. But we can't form up class with a decimal point like this. So you have to round it off to make it a full whole number. It's almost equal to
5.
5, correct. Okay? Because they ask you to determine the class interval, so we have to list out all the class interval. We cannot just stat 5 only. 5 is the class interval, but then you have to list down what are the class interval. Okay, so you have to re-answer the question. Therefore, the class intervals are, okay, we start with the lowest value. The lowest value that we have just now is 145. So 145 plus 5 is 149. Okay, not plus 5. You have to start with 145. So you need to count 145, 146, 147, 148, 149. Altogether, there are 5 numbers. So it's 145 to 149. Okay, followed by that will be 150 to 154 because it's a 5. Okay, I repeat that. It will be 150, 151, 152, 153, 154. Okay, followed by the next one, 155 to 159, and then 160 to 164. Actually, the difference is just a 444 if it is a 5. Okay, we have to finish until 173. So we continue with 165 to 169, and then 170 to 174, because you need to make it all equal, uniform. So 170 to 174 is 5 in the class. But then in the data, we don't have 174 here, right?
Yeah.
But then no matter how, the class interval, you have to step in so that all of it is a difference of 5 numbers. That is the class intervals. Are you okay?
Yes.
So you remember the formula is the largest value minus the smallest one. You divide by the number of class interval. Okay, so the one that we did in the mind mobilization, actually you also have to do so now, which is 15 minus 1, and then you divide by the class interval. Okay, now we look at B. Construct a frequency table based on the information in A. Hence, complete the frequency table with the lower limit, upper limit, midpoint, lower boundary, and upper boundary. Okay, so it's the same thing as what we did earlier. So I put down a blank for all of this. Okay, but then I think I don't want to waste the time by filling in because it's at 35 right now. I want to save your data. So I'm sure you know how to get all this. Do you know how to get all this? All right, open up the book for you. Do you have your book with you, class?
Yes.
Are you looking at your book?
Yes.
Yes. Okay, so you can look at the frequency of the first class, right? How much is the frequency of the first class?
2.
Yes, correct. You can see all this, right? Do you still remember how to get all the frequency of all of this?
Yes.
Okay, right.
Yes.
From 145 to 149, you find out how many numbers occur, so that will be the frequency. So the lower limit, you look at this, the lower limit is referring to the lower limit of the class over there. It's 145, and the upper limit is 149. That's how you get all this. And the midpoint is the number in between it. Okay, that is the lower limit plus the upper limit. You divide by 2, you will get 147. Okay, and the lower boundary is actually the lower limit of the class plus the upper limit of the class before it. So we don't have it here, which means this will be 146 plus 145 divided by 2, you get 144.5. And the upper limit will be 149 plus 150 divided by 2, you get 149.5. Are you okay for all of this table here?
Yes.
Yes, huh? Okay, I move on to this part here. For a group data in uniform class intervals, uniform means all of the class interval is uniform, 5, 5, 5, 5, 5, 5 each. The size of class interval can be calculated using two methods. Okay, the size of class interval. Next time, maybe they don't give you this, so they were asking for you to find what is the size of the class interval. So you can calculate the size of class interval based on the upper limit and the lower limit given. Okay, so you look at method 1 and method 2 given over here is very simple. The difference between the lower limit or the upper limit of two consecutive classes. Okay, for example, it is 150 minus 145. So you can refer to this, the upper limit 150, 145, you just minus, then you get it. Or you can use the upper limit here, 154 minus 149, you get the answer. Okay, so you can see that is the answer. Okay, whereby using the lower limit, the difference of it, or the upper limit, the difference of it. Second method is by using the difference between the upper boundary and the lower boundary of the class interval. So for example, for the first class, it is 149.05. Sorry, 149.5. You minus 144.5. So this is the one. 149.5 minus 144.5. You get a 5 by using the upper boundary minus the lower boundary. Are you okay?
Okay.
Okay, you just remember upper boundary minus the lower boundary, you get the class interval. Whereas for method 1, the difference between the lower limit or the upper limit of two consecutive classes continuously. Okay, so now we move on. Cumulative frequency. This one you learned already, so I'm going to do it fast. Cumulative frequency of a class interval is the sum of the frequency of the class and the total frequency of the classes before it. Okay, so for example, if I ask you what is the cumulative frequency for up to this part here, 3 here, can or not? Up to 3 here. The cumulative frequency will be 2 plus 3. So you get a 5. Okay, what about this one?
8.
How much is it? This one, for this part, what is the cumulative frequency for this data here?
19.
Very good.
19.
Okay, that is what is given in the information just now, whereby it is the frequency of that current class with the total frequency before it. So that is the meaning of cumulative frequency. Okay, I move on. This one, the cumulative frequency of a class interval is the sum of the frequency of the class. Okay, sum of the frequency of the class and the total frequency of the class before it. Okay, because you already learned this, so we move fast. Example 2 here, construct a cumulative frequency table from the frequency table below. So you're given the frequency table with the age and frequency like this. So you just rearrange it in the vertically, like this. Everything you just copy down. So to get the cumulative frequency, the first class will be just number 4 only. The second class over here, you just have to add on 4 with 5, you get 9. Okay, and then the third class over here, you add all of these 3 numbers before. So add plus 5 plus 4, you get 17. And this one, you add another 7, 17 plus 7, you get 24. And continuously for the last one, 24 plus 3, you get 27. That is how you get cumulative frequency. Okay, so we move on. I'm sure you don't have problem with that. Okay, histogram. We are going to learn to construct histogram now. Histogram is a graphical representation in which the data is grouped into ranges by using contiguous bars. Contiguous over here means they are sharing the same border. Okay, the height of the bar in histogram represents the frequency of a class. Step for constructing a histogram: find the lower boundary and the upper boundary of each of the class interval. Hopefully you still remember the lower boundary and the upper boundary will be the number in decimal, 0.5, 0.5. After that, choose an appropriate scale on the vertical axis. Vertical axis means the y-axis. Okay. After that, represent the frequency on the vertical axis and the class boundary on the horizontal axis. So you got to imagine the vertical axis, that one is the frequency. The horizontal axis, this one is the class boundary. Okay, this one represents the frequency. Now lastly, draw the bars that represent each class where the width is equal to the size of the class. So meaning if your class interval, the width is this much, that is your bar that will be constructed. And the height is proportionate to the frequency. So it must be the same as the frequency that is given. Okay, now we look at the frequency polygon. Are you okay? I talk very fast here.
Okay.
Okay, huh?
Yeah, madam.
Okay, frequency polygon is a graph that displays a group data by using straight lines that connect midpoint of the classes. That's why just now you learned all the 5 different things, the lower limit, upper limit, midpoint, lower boundary, upper boundary. So for frequency polygon, you will need midpoint. You've got to remember this. Frequency polygon, you need midpoint, which lie at the upper end of each bar in the histogram. So we will see this later on. Step for constructing a frequency polygon, you mark the midpoint of each class on top of each bar. Mark the midpoint before the class, the first class, and after the last class with 0 frequency. So meaning at the end of the class, you have to add on the 0 frequency to get the frequency polygon, something like that. And then lastly, draw the line by connecting all the adjacent points. All the adjacent point meaning that all the points next to it, you connect the line. Okay. Now we look at this one. Histogram and frequency polygon can only be constructed by using continuous data. What does it mean over here? For example, the data that we have earlier, let me see, is about height, right? Height. Continuous data means that the data must be non-stop continuously. This one. Oh, it's no number. I need to show you the number. We go back to this one. Okay, this one. Continuous data means the data is continuously. That's why, for example, if the height of the pupil is 149.5, it's not in the range over here, right? 149.5. Correct? No, it's not in this range, right? So how are you going to categorize if that pupil have a height of 149.5? That's why we have to add on the upper boundary, whereby the pupil with 149.5 meter will be categorized in this class interval. That's why they said the data is continuous. We cannot stop. Although they have 149.5 or maybe 149.6, 149.7, 149.8, then you have to decide where should we categorize those pupils. Okay, so I move on now. That's why they said can only be constructed by using continuous data. Now, look at example 3. Okay, the frequency table below shows the speed of car in kilometer per hour. They show you this frequency table over here, the speed from 70 to 79. A lot of you already know how to drive. So you can imagine from 70 to 79, the speed is already quite high, and then the highest one here is 120 to 129. Okay, recorded by a speed trap camera along in a highway in a certain duration. Represent the data with a histogram and frequency polygon. So we need to construct two things here, the histogram and frequency polygon. So you remember, for histogram, you will need all the lower limit, upper limit, lower boundary, upper boundary. But then for frequency polygon, you will need the midpoint. Okay, so by using a scale of 2 to 10 km per hour on the horizontal axis and 2 centimeter to 10 cars on the vertical axis. Okay, so for this example 3 over here, before you move on drawing your histogram, were you given the lower boundary, upper boundary? In the table here, were you given the lower boundary and upper boundary? No, right?
No.
No.
That's
No.
why before you construct histogram, you have to construct the frequency table first. Okay, with the lower boundary and upper boundary. Okay, so I move on. Okay, I'm going to drag this up. This one, they already add in the midpoint so that you can construct the frequency polygon easily later on. But if the question asks you to just construct the histogram, then you can exclude the midpoint, this one not need. Okay, but then in the question over here, because they ask you to construct both, so the midpoint is also added for the ease of your constructing later on. So first, we are going to find the lower boundary. How much is the lower boundary? Can you imagine? Look at this number here. It is the upper limit of the, lower limit of the class plus the upper limit of the previous class. So it will be 69 plus 70 divided by 2. Lower boundary is 69.5. Are you okay?
Yes.
Then the upper boundary is the upper limit of the current class plus the lower limit of the next class interval. So it's 79 plus 80 divided by 2 is equal to 79.5. So for the rest, we already can fill in. You can see the common thing over here means 0.5 before 70, 0.5 before 80 is 79.5. We continue, this is 89.5. What about the next one? What about
99.5.
Yes, correct, 99.5. Next one? 109.5.
9.5.
Correct. And then the next one? 119.5. What about this one? Upper boundary. First one already done, 79.5. So upper boundary for this one is?
89.5.
Correct. The next one?
99.5.
Correct. Followed by 109.5, 119.5, and 129.5. Are you okay?
Yes.
Okay. So still remember how to get the midpoint? Still remember how to get the midpoint? Midpoint is the lower limit plus the upper limit divided by 2. 70 plus 79 divided by 2. How much is it?
74.5.
Very good, 74.5. So we finish up everything. This is 84.5, 94.5, 104.5, 114.5, 124.5. Okay, so we have done the table already. Now we can construct our histogram. So you have to remember what do they ask you to do by using a scale of 2 centimeter to 10 kilometer per hour on the horizontal axis. That is the speed in kilometer per hour. And 2 centimeter to 10, the same scale, 2 centimeter to 10 cars on the vertical axis, the y-axis that will be representing the number of cars. Okay, so I'm going to show you fast with the graph over here. You already know, right? The graph over here from this part, this line to this line is representing 2 centimeter. Okay, if you got used to it, this one is 1 centimeter, 2 centimeters. So I'm just going to use it to draw the graph that is needed. Okay, so first I'm going to draw the horizontal axis. Oh, now I need to have my pen. I am going to use gray color to indicate that you have to use pencil. Remember, always draw the graph using pencil. Don't use pen, because I know a lot of you will like to use pen to draw it. Okay, something like this. So remember what is represented by the horizontal axis? Do you remember or not?
The class.
The class interval, right? That is representing the speed. So I write down first. We need to write down the speed first. Speed in kilometer per hour. Okay, and then I'm going to draw the vertical axis. You must make sure it's straight. So vertical axis representing what? The number of
Cars.
Number of cars. Okay, and then they said 2 represent 10, so I'm just going to mark it down, and then this is 20, this is 30, so start with 0. For the speed over here, I'm going to represent all of it using the table given. So the table over here, the speed will start at 70 to 79, up to 120 to 129. I have 1, 2, 3, 4, 5, 6. 6 class interval. So if they start with 70 to 79, we need to use the lower boundary and the upper boundary. Okay, so I'm going to start with 69.5 with the scale of 2 centimeter to 10. So I move back to my graph. 2 centimeters, so from 0 to here. I'm going to start with 69.5. Another 2, I plot all the 2 centimeter represent 10. So this part will be 79.5, 89.5, 99.5, 109.5, 119.5, up to, I think not enough. I need 129.5. So I'll go back again. I need to extend it. So this part I'm going to rub it off. Redraw again. Okay, the last one is 129.5, finished. Then, I make it simple. You just need to remember all the frequency of the car. So the first class is 5. So I'm going to memorize 5, 10, 20, 30, 25, 10. Can or not? 5, 10, 20, 30, 25, 10. So go back to the graph. I'm going to start with 5. So 5 is right here for the first class. The next class is 10. So 10 is right here. Followed by 20. 20 is here. You must draw exactly, I'm doing it fast, so mine is not very accurate. This one is 30. Followed by 25 and 10. So 25, we have to look for 25. This is 25. And the last one is 10. Okay, so when it's done, then you draw your vertical line. Simple. Oh, sorry. Okay, so this is histogram. We have done our histogram already for the first question. Do you have any question, class?
No.
No? Okay. Then we move on to the next one, the frequency table. So remember the frequency table, this one, we will need the midpoint. So we are going to plot all the midpoint on the histogram. Then you can see what is a frequency table. Okay, so midpoint is 74.5. I'm going to plot all the 84.5, 94.5 up to 124.5. Okay, go back to this one. I'm going to use the same color. So you can see this is 74.5, 84, sorry. This one is 84.5, correct? 94.5, 104.5, 114.5, 124.5. Okay, and then for frequency table, you have to make sure that you mark the midpoint before the first class. Before the first class over here, the midpoint is right here. Can you see my dot? Can you see my dot here in the almost nearly to the origin, the 0 there?
Yes.
Yes.
Okay, so we have to start with the class before the first class, the midpoint over here, or else your frequency polygon will be hanging. So you have to mark it down here. And also the last after the last class, the last one, you move to the last class. This is the last class. You have to mark for the last one here. Can you see my marking?
Can.
Yes, huh? So after that, then you join all the midpoint together. Join like this. Okay, then it is done. Okay, hold on, this one is gone. So we call this frequency polygon. Are you okay? Sometimes you can draw frequency polygon without going through the histogram. If the question asks you to draw the frequency polygon, you just need to find out the midpoint. You show the midpoint table. After that, you join up all the line together with the 0 in front and at the back. Okay, we will see the next question here. This is the answer for the one that we have just now. Okay, now this one. The frequency polygon can be constructed without constructing a histogram. So the steps are: add one class interval before the first class and after the last class with 0 frequency. That is what it means just now, because that is also what we do. We add one class before with a 0 frequency. This is the 0 frequency, okay, at the two ends over there. After that, find a midpoint for each class interval. Choose appropriate scale on the vertical axis. Represent the frequency on the vertical axis and the midpoint on the horizontal axis. If the scale is already given, then you follow the scale that is given on the question. If it is not given, then you have to choose appropriate scale. So that, mark the midpoint with the corresponding frequency, like what we did just now, and then connect each midpoint with a straight line. You understand, right? Okay, I move on to example 4. We are just going to talk about this one. So the frequency table below shows the time in seconds recorded by 20 participants in a qualifying round of swimming competition. So you look at this frequency table over here. It's recorded by 20 participants. So meaning that when you add up here, 5 plus 6, 11 plus 9, 20 participants. Okay, for a swimming competition, for the time recorded, 50 to 54 seconds, and so on. Now, represent the data with a frequency polygon by using the scale of 2 to 5 seconds on the horizontal axis and 2 centimeters to 2 participants on the vertical axis. So, on the horizontal axis and on the vertical axis, they already given you the scale, so you don't have to figure out anymore. So the first thing, remember, when you want to draw frequency polygon, you need midpoint. You only need midpoint to construct frequency polygon. So to find the midpoint again, can you tell me the formula to get a midpoint here?
Lower limit plus upper limit divided by 2.
Very good. So if you look at the class given, 50 to 54, this is the one, 50 to 54. So if I want to get the midpoint, it will be 50 plus 54 divided by 2. I get 52. Okay? And then remember, we have to add one class before it with 0 frequency and the class after it. That's why you can see this 2 is 0 over here. and these two classes doesn't appear in what is given in the question. See, the maximum is 70 to 74. So you have to add these two classes so that you can plot the 0 midpoint over here. So that your frequency tab, so your frequency polygon is not hanging like this. If it is hanging, you got 0 marks, okay? This one is usually in paper 2, the what you call it, the part that you can choose. So make sure you score full mark. I don't remember how much is the mark given for this one. That's why usually the SPM student, they will choose this chapter to answer so that they can score full marks, because it's very simple. You just need to draw either histogram or a frequency polygon or an ogive later on. Okay, so you add in and then you plot the point. So first one, the number of participants is 2. Okay, over here they give you 2 centimeter represent 2 participants already, right? Follow this one. So you have 2, 4, 6. The maximum is 6 participants. That's why we have 6. And then for the horizontal axis is 2 centimeter to 5 seconds. So 2 centimeter, we are going to plot the first one. Come first, 47. Okay. How to get 47? They are using all the midpoint right now. So you don't have to use the upper boundary, lower boundary like what we did earlier from the histogram. Okay, so this one you use the midpoint. From 47, we have 52, 50, 57, and so on. So you plot all the points until 77. Okay, plot all the midpoint. After you plot all the midpoint, then you join using ruler and make sure it is really connect from point to point. A very clean and smooth graph. Then you will get full marks. Okay, so it doesn't matter over here, whereby the range could be very big, but then you have to make sure you start with the correct midpoint. Okay, usually you will see we must make a uniform scale over here, right? Which is 0, 5, 10, 15, 20, like that. But not for this case over here. If they start with a very big value, for example, 1,000, then you also have to start with 1,000 over here. Understand, class?
Understand.
Understand,
Yeah.
So they add on a knot over here, add a class interval with 0 frequency before the first class and after the first class. So you have to add 2 class interval before and after with the frequency of 0 so that you can get the midpoint of it. Okay, so that is on how to draw a frequency polygon. So we will stop here for the lesson. For your exercise, you need to do 7.1a. Scroll down, let you see. 7.1a, you have to do everything. How many questions there? 1, 2, 3, 4. 4 questions. You have to do all of it. Up to you. You don't have to copy. I know it's very long. So you just need to solve everything given there. Do you have any question, class?
No, madam.
No.
Question.
Okay, thank you.